Hello everyone. In this session, we will be talking about one more new construction material, that is the reinforced cement concrete, so which is popularly known as the RCC. Right. Uh, we have seen in the last session about the plain concrete. So the plain concrete, it is nothing but it is a homogeneous mixture of cement, sand, and the concrete, sorry, and the coarse aggregate. So with this mixture we will be able to get a material called as plain concrete. So if you see the properties of the concrete is very much strong in resisting the compressive stress, but at the same time the concrete has almost negligible tensile strength, or we usually consider zero tensile strength for the concrete. But whenever we use this concrete in the construction activity, especially for the framed structures, like if you want to construct some beams, columns, slab, which usually have the flexural stresses, tensile stresses. So our concrete is good in resisting the compressive stresses, but at the same time it is very much weak in resisting the tensile stresses. To overcome this drawback of the plain concrete, during the 18th century when the industrial era has happened, so during that time people have proposed a new material where they have reinforced the steel bars, steel rods or steel bars into this plain concrete, and they are called that reinforced steel bars with concrete as a new material called as reinforced cement concrete. Now why this reinforcing the steel bars? There are two reasons. One is the steel is very good in resisting the tensile stresses, and also the thermal expansion coefficient of the concrete and steel, it is almost the same. So the temperature variation in the environment does not affect this combination. Now after reinforcing the steel bars into the concrete, the new material which is RCC or the reinforced cement concrete, which is strong in both the things, that is concrete is resisting the compressive stresses, whereas the steel which is reinforced in the concrete, it is resisting the tensile stresses. So both together RCC is good in resisting both cement as tensile as well as compressive stresses. So this concrete RCC, it is most widely used in almost every construction, especially whenever we have the necessity of going for multi-story. Like if you want to construct 2-story, 3-story, 10-story or 100-story, we need to go for the framed structures. So in the framed structures you can see we have the footings, columns, beam and slabs. The column will be a compressive members, whereas the beams, it is a flexural member where we have the tensile stresses. So to resist the tensile stresses and compressive stresses, we need RCC. Without RCC material, it is very difficult for us to go for the multi-story structures. This has become a most common construction material nowadays. So whenever if there is a necessity of going for only 1-story or ground floor construction in the residential structures, we might avoid the construction or the use of the concrete, because if it is only 1-story, then we can go with the our regular construction or regular masonry structures or stone structures. But if we are willing to go for the multi-story structures, then the use of concrete has become one of the mandatory. Apart from concrete also we have alternate materials, but let us not talk about those alternate materials right now. The concrete has one of the most widely used material now. Now what are the reasons why it is very much necessary, or I can say what it has become a most popular? That is basically what are the advantages of using the RCC. Let us see. So for producing RCC, as I said, we need basically concrete and steel, and concrete and steel are very easily available construction material in the market. So, the material which is required for the production of RCC, it is very easily available in the market. So, one thing is material used in RCC are easily available. So, that is one of the most advantage. Now, the second point is the durability and long lasting. Compared to the masonry structures or the brickwork, the RCC is more durable, means the life of the RCC structures, it is usually said that the life of the RCC structure will be around 50 years. The life of the structure is very long, it is a long lasting material, not like the other stone material or the wood construction activity where we can say the life is only about 5 years, 10 years, but here the life of the RCC structure is nearly about 50 years. And the next important advantage of the RCC material is it is having a very good fire resisting capacity. I am not saying that it is completely it is fire proof, but the fire resisting capacity of the RCC is very high. If the temperature in a building if rises beyond 500 degrees Celsius, in those situations we have observed that the strength of the concrete may reduce, it will not become 0, but it is reduced to some extent, but 500 degrees Celsius up to 500 degrees Celsius the RCC structures they will withstand the temperature, and it is not attacked by the termites. So, you can see that usually in the wooden construction activities for a year of 5 years and 10 years, then there is a usually it will go for the termite activity. The termite will eat the wood. So, they will lose the strength, whereas that situation not occur in case of the RCC. Now, the next one is economical in ultimate cost. If you see nowadays the construction of RCC we can achieve economy compared to the stone work or any other woodwork, because the stone is also costly nowadays as well as the wood is also costly. So, compared to these two basic construction materials, the next cheaper construction material is the RCC. As I said, there are other construction materials also, like we have steel, we have PSC, but those are also little bit costlier than the RCC. So, RCC is the most economic construction material as of now. And the maintenance cost, once you construct the RCC structures or the RCC element, like that may be footing or it may be a column beam, no maintenance is required till the collapse of the building or till the entire lifespan of the building. Usually maintenance is very less until something goes wrong with the entire structure, or else the maintenance cost of this RCC is almost 0. I can say that it is the negligible maintenance until some major issues with the entire structure, not specifically with the RCC material. And if I talk about the disadvantages are very less compared to the advantages. Even I can say that these are negligible disadvantages. The one is the scrap value is nil. Now, see, if you are going for the stone construction activity, so after the life of the stone work or a house or a building, so we can reutilize these stones, whereas RCC it is not possible because it is a concrete material reinforced with the steel bars. So, after the life of the building or the life of the structures, we cannot reuse the concrete work. So, it is almost the scrap value is 0, whereas in case of a steel or in case of a stone, we can reuse the materials, but not in case of the RCC work. And as I said, little bit constant checking is required. It is not necessarily, because if something goes wrong with the entire building or entire structure, so we need to observe what is happening with the building, where I can say that maintenance is 0, but we need to look into the structural behavior or how the building is behaving, or is there any deflections or any cracks in the RCC work, that we need to keep on checking. So, only check is required. And for the construction activity, we need little bit skilled labor. So nowadays the skilled labors is everywhere available, but the cost of the skilled labors is little more higher than the regular labors, right. So I don't think so the uh, disadvantages of the RCC are that important or that dominating as compared to the advantages. So we can say that the disadvantages are almost negligible or we can ignore. Nowadays, if you go everywhere or anywhere in the entire world, majority of the constructions are happening only through the RCC. So either the RCC we are using maybe in the form of foundations or for columns, beams or slabs. So without these RCC, it is very difficult for us to go for any of the construction activities or any of the construction nowadays, correct. So this is one of the most important or the regularly used construction material. So you can see in the picture where we can see how the things are going on with the construction or the RCC elements in the building. Now, moving on to the next construction material, that is pre-stressed concrete building. So this is one of the modified or the improved material, I can say. So we have some positive advantages and disadvantages in the RCC. So the disadvantages what we face during the construction and the design in the RCC, to overcome all those disadvantages, they have developed a new material called as pre-stressed concrete structures. Now let us see what is this pre-stressed concrete structures or pre-stressed concrete, or usually it is called as the PSC material. Now as I said in the discussion of the RCC, RCC is good in resisting tensile stresses as well as the compressive stresses. But when we use this RCC in the actual construction activity, especially in the flexural members means like either it may be a slab or it may be a beam, whereas the column is a compressive member basically. So when we are using RCC in the construction of the beams, so we have observed that in RCC there will be a development of both tensile stresses as well as compressive stresses simultaneously. And as our concrete is weak in resisting tensile stresses, whenever due to some reasons or due to the increase in the load on the structures, whenever there is a increase in tensile stresses in the concrete, we have seen that the concrete will fail because of these increased stresses, tensile stresses in the concrete, or the concrete will basically fails because of the excessive tensile stresses. And more or less we are basically during the design of RCC structures, we will be majorly concentrating on how to deal or how to manage the tensile stresses, because as we know that the tensile stresses are the major critical stresses where these stresses leads to the failure of the structures. Now they have proposed with some concept. This is not a new concept as you can say. This is a very old concept where people used to practice in the olden era, but unknowingly or knowingly we have made use of that concept into the concrete so that we can use that. What is this exactly? So let us assume that, so I have an RCC member, and when we apply some load on this RCC member, either it may be a UDL or a point load, it will undergo the deflection. So when it undergo the deflection, the top fiber of the beam, it will be under compression, and the bottom fibers of the beam, it will be under tension, right. So, that is why in the RCC usually we provide main reinforcement at the bottom at the center span, and at the end the main reinforcement will be at the ends, at the top. Now, at the mid span, the tensile stresses are developing at the bottom side, right. That is after the application of the load. So, here load may be either it may be a self weight or it may be a external load. Now, let us assume a situation where even after the application of the load, if a flexural member, if it is not developing any tensile stresses, it is a very important statement. Even after the application of the load on a flexural member like beam, if beam is not developing any tensile stresses, it means if the entire beam it is having only compressive stresses. Though beam is an flexural member, it means it is expected that there will be both compression and tensile stresses. But because of some setup or some arrangement, if a beam is not developing any tensile stresses, it means the entire beam it is under only compressive stresses. Then when there is no tensile stresses, I can say that there is no requirement of the steel. That is one thing. Then when the entire beam is under compression, as there is no tensile stresses, then the failure due to development of cracks or the deflection, it will be almost negligible, or you can say that there will be no failure of the concrete. Now, how this is possible? How a flexural member, how a beam is not having any tensile stresses? It is possible actually by a method of called as pre-compression of the members. That is, initially what we have to do is, to any beam or to any flexural members, if we are able to induce the pre-compressive stresses in the concrete by any means, either by combining or by pressing from the both ends or by using some technology, if we are able to induce some of the compressive stresses in the concrete before the application of the load, then what we are doing, we are intentionally developing some of the compressive stresses. And after inducing the compressive stresses, if I place that beam to the working position, then if we apply the additional loads on the beam. So, initially we have induced some of the pre-compressive stresses, then we are applying the external loads. So, what this external load will do? It will try to deflect the beam. So, during this process, what happens? The development of compressive as well as tensile stresses will happen. But as we have already induced some of the pre-compressive stresses, which will try to neutralize the pre-compressive stresses, they will try to neutralize the tensile stresses which are developing due to the external loads. So, ultimately what we will have a section where at the top side of the section we will be having the huge compressive stresses, because due to the external loads the top fibers will be under compression and already we have pre-induced compressive. So, both together it will becomes very high compressive stresses at the top side, and at the bottom fiber or at the bottom side the compressive stresses they will try to neutralize, or they will be able to neutralize all the tensile stresses. Means at the bottom fiber almost we will be able to see the negligible tensile stresses or zero tensile stresses, or might be we will end up with a very small compressive stresses, whereas at the top side we will be able to see a huge compressive stresses, and our concrete is very good in resisting the compressive stresses. So, by this method, that is by inducing some of the pre-compressive stresses into the concrete, we will be able to get a flexural member where we can say there is no tensile stresses at all. So, this method, this concept of inducing pre-compressive stresses into the concrete and having a new material where we can say that there is no tensile stresses. So, such a material is called as the pre-compressed structures or pre-compressive concrete. So, here as I said, so we have to induce the compressive stresses. So, for inducing compressive stresses into the concrete, so we have a system called as tensioning system. So, we have to do some tensioning system. The tensioning is done either through the steel wires or cables, or sometimes we may use the tendons depending upon the type of the or depending upon the requirement. So, if you see the system of tensioning, so what exactly we will do? First we will tension a tendon or tension a wire. So, tensioning a wire means we are stretching the wires. So, initially we are inducing tensile stresses into the concrete, sorry, into the steel wire or a tendon. Then around this tensioned tendon, what we are doing, we have to construct or we have to framework the structure or member. For example, if I am trying to pre-compress a beam, then first I will be tensioning the wire, then around this wire or tendon, I have to go for the concreting as per the requirement. Like if I am trying to have a concrete beam, then I will be fixing some width and some depth around that. Then inside that I will be having this tensioned tendon or the wire. Now, once we have this beam, that is one entire framework is ready, then I am supposed to pour the concrete and allow the concrete to attain the hardness. So, what happened here is, first I have tensioned the wire, then around this tensioned wire I have constructed a beam or I have casted a beam. Now, once this concrete attains the sufficient hardness, what it will do? It will hold the tendon firmly, right. It will hold the tensioned tendon or tensioned wire firmly. Now, once the concrete attains sufficient hardness, what we have to do? We have to release the forces which we have applied to tension or to stretch the tendons. As this tendon, it is basically a steel material, or I can say it is an elastic material. So, once you release it forces, what this tendon or this steel wire will do? It will try to go back to its original position. Initially we have stretched it. So, once you release the forces, it will try to come back to its original position. But the concrete which we have casted around the tendon, it holds the tendons firmly. It will not allow the tendon to come back into its original position. But in this process, the amount of force we have applied to stretch the tendon, it will get reversed, right, and it will act as a compressive force on the concrete. So, this is a method or this is a technology where I can say that I am trying to apply a compressive force at both ends of a beam. By this method or by this technology, I will be able to induce, I will be able to generate some of the compressive stresses in the beam. Right. So, this method of called is called pre-stressing method or pre-stressed concrete. Now, here there are two different types of tensioning. One is called as the pre-tensioned and another one is the post-tensioning. So, this method it is basically classified or basically suggested when we are tensioning the tendons or when we are tensioning the wires. So, as I just now explained here, the tensioning of the wires or tensioning of the tendons is done before the placing of concrete. So, this method is called as the pre-tension, means before the concrete placing, if you are tensioning the tendons. So, this method of tensioning is called as the pre-tensioned pre-stressed concrete. Now, sometimes what we do, first we will cast a beam with a hole or a groove inside the beam. Once the concrete gets sufficient hardness, then we will be inserting a tendon or a wires in the groove, then we have to stretch the tendons. So, here what we are doing, we are tensioning the tendons after the casting of the concrete. So, this method of tensioning is called as the post tensioning method. So, these are the two basic methods of tensioning. Now, there is many things are there. Let us not talk about all those things. Let us see what are the advantages of pre-stressed concrete over the RCC. Now, if you see the life of the PSC members compared to RCC, it is much more greater, because in case of RCC we will be able to see there is a development of tensile stresses which may lead to the failure. But here in the PSC there are no tensile stresses. So, the life of the PSC members or the PSC concrete, it will be much more greater than the RCC structures. Now, the second advantage is the dead weight of the PSC members, it will be comparatively very less as compared to the RCC, because in any flexural member there will be two parts. The first part is to resist the compressive stresses, and the second part is to resist the tensile stresses, which we call as compressive zone and tensile zone, right. In the beams or in the flexural members, the portion where we have the compressive zone, only that portion will be effective. The portion which is there in the tensile zone, the concrete which is there in the tensile zone, it is of no use. The only purpose of the concrete in any flexural member in the tensile zone is to hold the reinforcement in the position. Other than, there is no use of the concrete which is there in the tensile zone. So, that is why in RCC member the sectional dimensions are little bit higher than the actually what they required. For example, if I have a beam of dimension 230 width by 450 depth, then I can say that in the 450 depth might be the effective concrete what we using or utilizing, it is maybe around some 200 or 230 or maybe 250. The remaining portion of the concrete is of no use. So, it is unnecessarily increasing the dead load in the RCC structures. But in case of PSC, the entire cross section it will be under compression. So, the entire cross section is utilizing the for the design purpose or to hold the loads. So, the section dimensions required for a PSC members, it will be much lesser than what it is required for the RCC members. So, usually the dead weight of the structure will be less because they need smaller sections. Then the material cost is less. Why material cost is less? Because here in RCC we are using concrete and steel rods or the reinforcing bars, whereas here we are not using any reinforcing bars, because as there is no tension stresses, no requirement of the reinforcing bars. So, the cost of the materials which we use for the construction of the PSC, it will be comparatively less. Next, the long span structures. So, whenever the span is more, span is greater, then the depth of the cross section will also be keep on increasing as the span increases, right. But here in case of PSC, as the entire section is effective in resisting the loads, the depth of the sections for a longer span requirement will be very less. It means even for a smaller sections, we can go for the longer span elements. But here as the span keep on increasing, the depth of the beam is also keep on increasing, which it will become a critical. So usually we don't go for the higher spans in RCC, whereas we can go for the higher spans in the PSC beams. That's why, that's the reason nowadays you can see that the majority of the flyover construction, they will happen through the or with the help of the PSC elements, not with the help of the RCC elements nowadays. Might be if you go to any metropolitan cities, then you will find that all the major flyover construction, they will use the PSC as a major construction material. Right. Okay. Next, we'll move on to the disadvantages. So, as like there is no much disadvantages in RCC members, we have some major disadvantages in case of PSC member. The first or the major disadvantage is the cost of the PSC is comparatively very high as compared to the RCC members, because RCC members we can easily cast in the field, whereas PSC members we cannot do this in the field. We need to tension the tendons or tension the wires in the factory, then we need to create the molds, we need to cast the things. So, we need a huge technical equipments, we need a larger equipments. So, the cost will be comparatively high for the PSC members in comparison with the RCC members. Next, as the PSC involves many huge equipments, we need the skilled labors. The skilled labors requirement is very much necessary in case of PSC, whereas in case of RCC we need only few skilled labors. And the next drawback in PSC is the PSC is not that applicable or not suitable to apply for the smaller works. For example, if you have a construction of a two-story building, then if you are planning to apply the or planning to use the PSC members for the construction of the two-story building, then I don't think it's a good idea, because the cost will be very, very high as compared to the regular or conventional construction method, that is using RCC. So, usually for the smaller constructions, it is not advisable to use. If you have a major construction activity, like if you have a flyovers, then we can use the PSC as one of the major construction activity or major construction material, right. So, this is the two important construction materials, one is RCC, another one is the PSC. Okay.